Hello, curious minds. Ever wondered if time travel is possible or if black holes could be our gateway to different times? Today we're exploring the intriguing connection between these two phenomena. There are countless myths and misconceptions out there, but we're here to delve into the scientific perspective. We'll break down complex theories into digestible information, dispelling the fog of fiction to reveal the reality underneath. So, are you ready? Stay tuned as we dive deep into the fascinating realm of time travel and black holes. So, what is time travel? You might have seen it in sci-fi movies, but what does science say about it? Well, time travel, in its simplest form, is moving between different points in time, just as we move between different points in space. But unlike space, we can't just hop in a car and drive to next week. So how can we travel through time? This is where the concept of spacetime comes into play. Spacetime is a four-dimensional fabric where the three dimensions of space and one of time are intertwined. It's like a cosmic grid that stretches across the universe. Albert Einstein's theory of general relativity tells us that massive objects like planets and stars distort this grid. Imagine a bowling ball resting on a trampoline. The ball creates a dip or curve in the fabric of the trampoline. That's what massive objects do to spacetime. This distortion creates what we experience as gravity. But what does this have to do with time travel? Well, according to Einstein, not only does mass distort spacetime, but it also affects the flow of time. Time ticks slower in strong gravitational fields. This is known as time dilation. A practical example of this is seen with astronauts in space. When they return to Earth after a long mission, they are actually a few microseconds younger than they would have been if they had stayed on Earth. That's because time runs slower for them due to the weaker gravity in space. So theoretically, if we could create a gravitational field strong enough, we could slow down time to the point where we could leap into the future. However, traveling to the past is a lot more complicated and controversial. Some theories suggest using wormholes or cosmic strings, but these are highly speculative and not yet supported by empirical evidence. Now that we have a basic understanding of time travel, let's tackle the mystery of black holes. Black holes, the enigmatic giants of the universe. But what exactly are they? Black holes are a phenomenon as fascinating as they are mysterious. They are regions in space where the gravitational pull is so strong that nothing, not even light, can escape from it. The idea of such a powerful force existing in our universe is simply mind-boggling. So, how do these cosmic behemoths come into existence? The birth of a black hole can be traced back to the life cycle of a star. When a massive star exhausts its nuclear fuel, it undergoes a catastrophic collapse under its own gravity. This collapse leads to a supernova, a stellar explosion that can outshine an entire galaxy. The remnants of this explosion, if sufficiently massive, can form a black hole. Now let's talk about their properties. Black holes are characterized by their event horizon, the boundary beyond which nothing can escape their gravitational pull. This is the point of no return. Then, there's the singularity at the center of the black hole, a point where the laws of physics as we know them break down. The impact of black holes on spacetime is another fascinating aspect. You see, according to Einstein's general theory of relativity, massive objects distort the fabric of spacetime around them. Black holes, being the most massive objects we know of, cause the most significant distortions. This means that near a black hole, time slows down, a phenomenon known as time dilation. So, picture this. If you were to observe someone falling into a black hole from a safe distance, you would see them slow down as they approach the event horizon, and eventually they would appear to freeze in time. Intriguing, isn't it? But how do black holes and time travel connect? Let's find out next. One might wonder how these two fascinating concepts, time travel and black holes, are interconnected. Well, it's all about the fabric of space-time, a term you've probably heard before. Imagine the universe as a two-dimensional rubber sheet. When something heavy like a star is placed on it, it bends the sheet. Now if you replace that star with a black hole, it doesn't just bend the sheet, it punctures it, creating a tunnel to another point in spacetime. That's where wormholes come into play. Think of them as shortcuts through the universe. They are theoretical passages through spacetime that could create paths to different times and places. Some theories suggest that black holes could be the entrance or exit points for these wormholes. Albert Einstein's general theory of relativity, which describes gravity as a warping of spacetime, permits the existence of wormholes. However, whether they can be stable enough or large enough for a human or a spaceship to travel through remains uncertain. One theory suggests that if a black hole spins, it could potentially stabilize a wormhole. This is based on the idea that the rotational energy of a black hole might counteract the natural tendency of a wormhole to collapse. However, this is purely theoretical and has not been proven. Moreover, there's the concept of singularity within a black hole. It's a point where all the laws of physics as we know them break down. If one were to enter a black hole, they'd be stretched into a long string of atoms before reaching the singularity, in a process humorously called spaghettification. Not exactly your ideal mode of travel, is it? So, while black holes and time travel are captivating subjects that tickle our imagination, the current understanding of physics suggests that using a black hole as a portal for time travel would be incredibly risky if not impossible, with our current technology and understanding. The possibility seems exciting, but is it really feasible? Let's explore that. Time travel using black holes. A fascinating idea. But is it just a part of science fiction, or does it hold any scientific credibility? As we delve deeper into this topic, we come across various myths and misconceptions. Let's address a few and understand the scientific challenges associated with time travel and black holes. Firstly, the most common myth. If you enter a black hole, you can travel to the past or future. Well, this is more of a Hollywood concept than a scientific one. As per our current understanding, black holes are regions of space where gravity is so strong that nothing, not even light, can escape it. So the chances of surviving a trip through a black hole, let alone traveling through time, are slim to none. Next, the misconception that time travel is possible because Einstein said so. While it's true that Einstein's theory of relativity does allow for the possibility of time dilation under extreme conditions, it doesn't imply that we can hop into a time machine and visit any era at will. The conditions required for such dilation, like traveling at near light speeds or experiencing intense gravitational fields, are beyond our current technological capabilities. Now let's address the elephant in the room, the feasibility of time travel. As intriguing as it sounds, time travel, especially with the help of black holes, is currently beyond our grasp. There are immense scientific challenges to overcome. For instance, the immense gravitational force of black holes, the question of how to survive such a journey, and the unavailability of a mechanism to control the destination or the time period to which one would travel. Moreover, even if we overcome these hurdles, there are philosophical and ethical questions to consider. What happens if you change something in the past? Would it create a paradox? These questions add another layer of complexity to the already challenging concept of time travel. So, it seems we still have a long way to go before we can plan our vacation to the past or future. But remember, science is ever evolving. What seems impossible today might just be within our reach tomorrow. So, keep exploring, keep questioning, and keep your curiosity alive. Well, there you have it. The mysteries of time travel and black holes a bit clearer now. We've embarked on a journey through the corridors of time, exploring the enigma that is time travel. We've delved into the depths of black holes, these cosmic phenomena that continue to baffle and intrigue us. We've established how the two are intertwined, how black holes could potentially serve as gateways into the realm of time travel. We've also addressed the many myths surrounding this topic. Time travel is not a realm of science fiction alone, it's a scientific concept rooted in the very fabric of our universe. However, it's important to remember that our current understanding is still limited. The feasibility of time travel, particularly through black holes, remains a topic of ongoing research and debate. Science is a constantly evolving field. Each day brings new discoveries, new theories, and new possibilities. Today we stand on the cusp of understanding the mysteries of time travel and black holes. Tomorrow we might be standing on the other side looking back at how far we've come. So, stay curious and stay engaged. Your thoughts and insights are invaluable in this journey. The world of science is a shared adventure, and your participation makes it all the more exciting. Thank you for your time, and remember, science is always evolving. Who knows what we might discover tomorrow? Don't forget to subscribe and leave your thoughts in the comments below.